problem, they'll go straight to the packages without knowing what's underneath it and just put in those packages. So I usually have them go back and say, do that example for me in Excel. And that's a way where you can get under the hood. So it's really nice to do it in Excel because you can see everything. And if someone's programmed something in Excel, they had to know what like you have to kind of know what goes into the pieces. So the differential equation I'm numerically integrating is this guy, y prime equals y minus t squared plus 1, which, by the way, you can solve it by hand. We should do that in class. Solve it by hand and then graph the actual solution next to this. That's kind of one of the things I wanted you to do in class. So we'll do that too. This is a integrating factor. Or you can just put on Mathematica and tell it to solve it. This will give you the exact solution. All right, so how does this work? This first column is my i's. In your code, you're actually going to have a for loop in there, or some kind of loop, where you're looping from I equals 1 to n. N is like how many pieces you've chopped your interval into. So I'm going to give you some pseudocode in a second to show you how that works. But what I do is I start out with the h first, my step size. So I already decided my step size is going to be 0.01. I'm kind of lazy. I just say, okay, I'm going to do what always works for me, and 0.01 seems small enough. So I just set this I up in Excel as a counter. And how you do that, I just scroll down with the formula. Does everybody know how to do this? Just scroll down the formula? Okay. Then I put in the t's. Whoops. So in the t column, I just have it go up by 0.01. And now what's my capital N? That you need for your code that you're writing up for homework. You need to know what the capital N is. I don't like division, so I just went through and looked at it. If I wanted to integrate from 0 to 2, which is what I think at the example I saw, they wanted it to be integrated up to 2. I just went and looked over here. My capital N is 201. That's how many pieces I've chopped up the interval into. So if you want to, and you don't want to do the arithmetic, sometimes I'm off by right below it or one above it. It'll make your code crash if you're one above it. If you put 202, it doesn't know where to go because you've made your step size h equals 0.01. So you got to have everything line up and match. This is the lazy man's way to do it. You could just scroll it on Excel and see where it all matches up. So you don't get above or below your capital N. You need to know what a capital N is to match up with your H. Then my initial condition that was given to me, this guy here was given to me in the problem. This came from a book called Burden and Fairs. We still teach out of that book. I learned out of that book. That's the Bible for numerical analysis. So they have Runge Kutta inside that, and there's a free PDF online. You can just look at it and see if you want to go back and see the problems actually being written out. What's nice is if you take a problem from there, you can see if it matches up in your code with your code and their final graphs. So this was given to me. The initial condition was given to me. And then I have to go calculate the K1, K2, K3 from the formulas. Let me see if I still have that here. Yeah, there you go. So I'm just going to lift this up. I know it's annoying to look at, but I want you to see the formula. I should have put it on the other board. So if you go into this K1 cell, what I have in that K1 cell is I have this part 0.01 is my H. So I just take H times 0.01. The formula is gone. Yeah, I just erased the formula that was here. It should be on your sheet though. So you're supposed to do H times F of the point Tn comma Yn. So right here I have H, which is 0.01, times my F is this guy here. Inside the Y, both the initial condition and my initial condition are in the cells C2 and B2. So, and inside for the T goes the initial condition. And I put them as formulas because I want to just scroll the thing down and have it recalculated. That's my loop. That's Excel's version of a loop. And so if I go over here, I see like I told it to take B2 and square it. That's this guy, B2 and square it. The Y was C2. That's right here, 0.5. And subtract that and add 1. So this is my F of Tn comma Yn. That's what that piece is. Then I move over to the K2. In the K2, I had to do some more monkey business. So I had H times C2, right here, this is the Y, plus 1/2. So in for the Y value goes YN plus 1/2 HKN1. KN1 is this in the D column. So that's why KN1 is right here. So you can see them exactly mapped to this formula. It's annoying in Excel because you have to kind of remember that you can't see both cells at the same time, what you typed in the first one. So you have to kind of remember what you did. So then all I did is I wrote each one of these out. And of course, it's reaching back into this column here. That's why I told you in your program, that has to come first so you can reach and put it into the K2. And I didn't call them KN1, KN2 because I'm just going to update them. In my code, I'm just going to update that. All right, so that's all of these guys. And then this here, my P gets updated, and my new YN gets updated. So the YN is going to be that first formula I gave you. You take all the K's from the previous step, weight the two midpoint ones, and divide that by 6, and add it to your previous YN. And that gives you your new YN. Evan?
For the K terms, how do you put the H on the outside?
0.01 is my H.
Right.
So if I wanted to like, we can do that actually. We can go over to let's put an H here. So here, hence it's funny, it's H, it's actually H. $8 too, because I don't want that to scroll. And this one it's on the outside. Oh, I see what you're saying. I put it on the outside, inside each of the K's instead of putting it on the outside of.
Still works.
Well, yes.
I'm just having trouble seeing the distribution of it because, like, you gave us the formula for K of F of C9 plus 1/2 H.
Yeah, it's inside here. See, let me go back then.
So
I just put 0.01 inside here.
The original equation, right? Well, it's y plus 1 is equal to yn plus h times all of the k's add together to 6. So she just put the h on each value rather than multiplying it when we calculate the w.
Yeah, so yeah, I think that Burden and Ferris just has it on tacked on each one of the K's. So I could have just written the K's as all, but I gave you the formula with H on the outside. And so I kind of put all the H's next to this, and then it's distributed log. So I have that now. Did I catch all my H's? Okay, so I could just now scroll this down. And then now I can change my step size and see the difference. Oh, something happened. Undo.
The formula was fine to put 0.1.
Where did I do that?
For the h, when you're typing in, put 0.1.
Okay. Now I can see what, so it doesn't, the answer to the question, can I put 1 in for my h? Please don't do that. Like, that's not a good thing to do. 0.1, it shows it to be unstable. That seems more reasonable. Let's solve this by hand. Let's solve this by hand now, because that's how you test a numerical method. You try it on something that is solvable. That was my senior thesis, actually. My capstone was taking something called the Burger's equation, which is a PDE, which we know how to solve it exactly. And then I had a numerical method. It was the one that was used by Edward Lorenz in the Lorenz attractor. And I tried it on the Burger's equation, and I compared it to the exact solution just to see if does it work. All right, let's try it. You guys should be able to solve this. This is integrating factor. You can either do it by hand or run it on Mathematica. You solve it. Initial condition is 0.5. You can actually put in the initial condition.
I get help understanding. Like,
Sure.
I'm just not seeing it, like with the lowercase.
So I put what I did. Let me, yes.